thing to speak sitting down. It feels like I'm the Speaker of Parliament. Honourable Member, I will throw you out if you continue with that behaviour. Good evening. I would like to recognize the chairperson of the board of the National Research Foundation, Professor Robin Krug. We also have the international guests from the Japan Society for the Promotion of Science, the resident director Soichiro Shiraishi, and the deputy director for the international program department, Saito Kiyoshi. We would like to welcome them. Ladies and gentlemen, we also have the people who will be joining us from New York, and they will be listening to this lecture through webcam. We also have those who are listening at home, more than 500,000 who are listening over the radio. So we are quite a much more bigger audience than we seem to be in this room. Ladies and gentlemen, without wasting much time, you know, as Africans, you need to be welcomed by the head of a household before you can feel any comfortable. Before we begin, I'd like to invite Professor Helder Marx, who's the Dean of the Faculty of Science and Vets, to welcome us on behalf of the university, and Professor Zebulon Vilakazi, who's the Deputy Vice Chancellor, who could be here this evening. Professor Marx.
I think everything is worked out perfectly in a way.
Yeah, no, it sounds fantastic. I mean, I suppose in a way you're fortunate because...
Thank you very much. Ladies and gentlemen, my name is Helder Marx. I'm Dean of the Faculty of Science here. Professor Zebulon Vilakazi, unfortunately, has been detained and will be joining us a little later. On behalf of Wits University, it is my extreme pleasure to welcome you all to this lecture, the latest in the NRF Science for Society lecture series. The series is an important initiative on behalf of the NRF, because what it really seeks to do is to bridge that divide that sometimes perceived, sometimes unfortunately real, that exists between science and community, in order to foster a better understanding and appreciation for what it is that scientists do and the importance of our fundamental product, which is knowledge. And really, this public communication of science is something that we think is extremely important. Now, our attention tonight is on paleoanthropology, and we have two speakers, which I'll introduce to you very briefly, and then during the radio broadcast itself, a more formal introduction will be made. First is Professor Berger. Lee, you want to stand up? Lee is a research professor in human evolution and, importantly, in the public understanding of science. So I think he's really the ideal person to speak at an event like this. And he's also an explorer in residence at the National Geographic Society. Next to him, Professor Bruce Rubidge, who is Director of the Centre of Excellence in Palaeosciences and is the Interim Director of our Evolutionary Sciences Institute. So ladies and gentlemen, welcome to this event, welcome to this university, and I hope you enjoy yourselves.
Thank you very much, Professor Marx. As you all know, we've advanced in terms of cellular phone technology. So I would please like you to switch it off. These days, you don't get much feedback when you keep it on silent, but with this technology, it will still give us feedback if you keep it on silent. So please, we request that you make sure that your phones are switched off for the duration of the lecture. Ladies and gentlemen, I'm going to invite to the podium Dr. Berger, who's the Group Executive for Science Engagement and Corporate Relations at the National Research Foundation, and she is the custodian of these programs, to give us an introductory remarks. Thank you.
ladies and gentlemen. Thank you very much for responding to an invitation to a lecture that, as soon as we put the topic out there, just draws an instant response. I think it is, we talk about human evolution, but when we just really think about it, it draws an interest that is hard to explain. As the National Research Foundation, we've really placed an emphasis on the importance of science engagement. The National Research Foundation funds especially high-end instruments like the Centers of Excellence and the South African Research Chairs Initiative, where you have top-end, cutting-edge researchers and knowledge generation. What we want to really promote is that these top-end researchers and the kind of knowledge that they produce is made available in an accessible, exciting form to the public, because it is public funding that is helping to generate some of this knowledge in many instances. And so as NRF, we're really proud of this initiative, which is really rolling out in full in this past year, where we've created a partnership between universities, a media platform, in this case Radio SAFM, and then the public audiences that we get to, and the scientists themselves. And we've been going around the country, being hosted by different universities, engaging with amazing speakers and getting really good feedback from the audiences. So thank you very much to our two speakers that are going to be engaging with us today, and also with the broader audience that is out there. So I do say do enjoy it. It is always a good experience. Sometimes for some of us, this radio experience is a bit of a disconnect, because we keep forgetting we have to listen to the news and then take sports. But that's part of public engagement, and realizing that the science gets immersed into that particular process. That's exactly what we want to do. I know WITS itself is committed to science engagement. I've spoken to a lot of your researchers and your corporate office who is driving that. So I think we are in a place who welcomes the kind of efforts and working with NRF in promoting public engagement with the very good science that comes out of your institutions. So thank you very much.
Thank you, Dr. Mons. Ladies and gentlemen, as Dr. Mons has already mentioned, don't worry, we'll might listen to a bit of sport and news from Rubidge, which helps some of us who don't really have time to listen to some news and to understand what's happening. So now, from now on, we'll head over to SAFM, and they will run the program from here on. There will be time for you to ask questions, and we will circulate small pieces of paper that you will put your name and question on, so that the question time is quicker and we know who to go to in terms of the questions. And we will also have time to give those who are listening over the radio to have their questions as well. Thank you very much, and I hope you really enjoy it. I'll hand over to Master Chaba. When the time is right, she will come back to you. Thank you.
On accusations of political posturing, as they're based on inaccurate quotations from the statements. The ANC caucus of Parliament has described the DA's request for the establishment of a process to keep President Zuma as an electoral ploy, as his name is grabbing the DA, which the DA's chances in this year's poll. Cezanne told the media that they cannot report candidates in Parliament.
It will be very challenging for Parliament to take impeachment on the street. Yes.
The ones that were identified in the chapter and their local affairs officers are part of it. As he says, several officials who were painted as regular payment. Charges against Julius Levin's business partners facing charges of fraud, racketeering, and money laundering. On counter, financial fraud, kickbacks, gained a 52 million
A very good evening to you. Good evening, hi. My name is Master Chaba Mdolo. I'm the host of the talk shop on SAFM, and I will be at sea tonight, completely at sea. So please bear with me. I will be introducing our guest speakers, and I will be facilitating the question and answer session. Normally, we have a very long question and answer session, and that is because I think we're all very familiar with the socio-economic challenges that we face in our country today, and that is some of the issues that we focus on. But tonight, I will hand over to you. I will be taking your questions, comments, contributions much earlier on. So please feel free to engage us. Let's open up the discussion. And remember that you gathered here are more the experts on this issue than I am. So thank you again very much for coming through. And let's enjoy.
This new satellite image is the best lead so far. Provided by a French company, it shows a large number of objects scattered in relatively close proximity. The objects are spread across a wide area, close to where a tiny satellite identified something larger focused a week ago. But although there's still no provable link in later airline claims, investigators do expect.
Experience quality accommodation, service and hospitality when you stay at one of our star-rated establishments. Visit tourism.co.za. Cape Town International Jazz Festival celebrates 50 years of excellence and 20 years of democracy. This year at the CTICC on the 28th and 29th of March. 5 stages, 2 nights, 40 international acts. For all the details of the free jazz workshop and the full lineup, go to www.capetownjazzfest.com or follow us on Facebook and Twitter. This is the Art and Culture and the SAUC.
The problem is that I can't go to the bus because I don't even know what that house is. Here my problem is take a whole step by step. What the world is for?
The Talk Show.
A very good evening to you and welcome to the talk shop on SAFM 104 to 107. I am Master Chaba Mdolo. Tonight we are back in Johannesburg, but no, we are not in our studios. We're broadcasting from the National Research Foundation's Science for Society lecture series at the Senate House complex at the University of the Witwatersrand, and we'll be looking at Palaeosciences. The National Research Foundation's Science for Society lecture series is delving into paleontology tonight under the title Palaeoscience charts the course of humanity's past. As per usual, a bit later on after the presentations, we will be taking your calls on 0891 104 207, 0891 104 207, or you can SMS us on 34701. SMS number is 34701, and SMSs are charged at R2. Palaeoscience, like the subject it studies, evolves as new information on the origins of humanity is unearthed. The further we advance in our quest for answers, the stronger our links to the past, present, and the future become. It will all be clear later on tonight after our speakers have spoken. We're joined by Professor Bruce Rubidge, Director of the NRF DST Center of Excellence in Palaeosciences and Interim Director of the Evolutionary Studies Institute at the University of the Witwatersrand. Also joining us is Professor Lee R. Berger, Research Professor at the Evolutionary Studies Institute and an advisor for the Center of Excellence in Palaeosciences at the University of the Witwatersrand. As per normal, at the lectures we will have presentations from our guests and thereafter open up the floor for our audience here at Wits University and for you at home via SMS and calls to engage. Again, our number is 0891 104 207 or SMS 34701. SMS number is 34701 and SMSs are charged at R2. When we come back, I'll introduce you formally to our guests. Okay, it looks like we are not going to be taking a break at that point. I am aware that we need to pay the rent, but maybe we can pay the rent after I've made you aware of what the NRF DST Centers of Excellence are all about. Well, this year they celebrate their 10-year anniversary. They are physical or virtual centers of research, which concentrate existing capacity and resources to enable researchers to collaborate across disciplines and institutions on long-term projects that are locally relevant and internationally competitive in order to enhance the pursuit of research excellence and capacity development. The Center of Excellence for the Palaeosciences is the 9th in the program since its launch in 2004. So tonight we're going to be hearing about fossil hominid sites. We'll also be hearing about Australopithecus sediba. I'm looking forward to that. And we'll also be talking about how we move forward as a society, as a community, taking into account where we come from and what these fossils are teaching us about what was taking place in the past and how we can offset some of the challenges then today, or deal with the challenges that we're facing today. We're going to take a short break now, pay the rent, and when we come back, it's a formal introduction to our guest speakers.
SAFM is giving you, our Cape Town-based listeners, a chance to receive double tickets to this year's Cape Town International Jazz Festival at the Cape Town International Conference Center on the 28th and the 29th of March. To stand in line to receive these tickets, SMS the keyword jazz and your name to 34766. SMSs cost you R1.50. Free SMSs do not apply. Day pass only. SAFM and all that jazz.
SAFM brings you live, interactive, topical news from current affairs, global warming debates, women's issues, to interviews with top literary connoisseurs. To join our conversations, visit our website on safm.co.za. Follow us on Twitter at SAFM Radio or simply like our Facebook page, SAFM Radio. SAFM, South Africa's news and information leader. The Talk Shop.
This is the Talk Shop coming to you from the National Research Foundation's Science for Society lecture series at the Senate House complex at the University of the Witwatersrand, and the topic under discussion tonight is Palaeoscience charts the course of humanity's past. Our first guest speaker is Professor Bruce Rubidge. He is Director of the NRF DST Center of Excellence in Palaeosciences and Interim Director of the Evolutionary Studies Institute at the University of the Witwatersrand. Professor Professor Rubidge has administered and sponsored research on the Cenozoic fossil hominid sites in the cradle of humankind and supervised postgraduate geology and paleontology students researching the Devonian rocks of the Cape supergroup, as well as worked on research projects relating to the paleontology, sedimentology, stratigraphy, and basin analysis of the Permian-Jurassic Karoo supergroup. He is a former head of the Karoo Paleontology Department at the National Museum in Bloemfontein and is a director of the Bernard Price Institute for Paleontological Research at Wits. Before you start, Professor Rubidge, just a quick reminder that these are the Science for Society lectures. So please, bear with us and stay with us. All right, Professor Rubidge.
Thank you, ladies and gentlemen, for your warm reception. And it's a wonderful opportunity for Lee and I to be engaging with the public of not only here at Wits University in Johannesburg, but also the whole of South Africa, and to tell you a little bit about the excitement of the paleo history of our wonderful country. Must I use this mic rather? Both? Okay. We've all been told that we're going to be looking at this course of humanity's origins, and you will see from the lecture that I'm going to give that humanity has a very deep origin and starts billions of years ago. This, to show you just a little bit about the excitement of South Africa's fossil heritage, this is the site that we found a week ago down at Sutherland. This is a fossil footprint site. It's 20 meters long, and you can see there's an animal that's walked along here. It's got a tail drag going down there, and if you look at it in close detail, you can see even the little drag marks of the feet as they drag their claws over the mud in this slide over here. Now that gives you an indication of just some of the exciting things that we've got in South Africa that are new and are found.
Professor Rubidge, we are going to request so that the mic be as close as possible.
So
just imagine you're a sportscaster tonight.
Well, it's quite difficult to do that. If we look at a geological time spiral showing the development of the history of the Earth and life on Earth, you'll see that Earth originated about 4.5 billion years ago. And if we follow the spiral round and round and round, at about 3.5 billion years ago, we get the earliest evidence of life. And that comes from South Africa. It's found near Barberton. We'll talk about that just now. We go on and on round the spiral, and eventually at about 700 million years ago, we get the earliest multi-celled organisms in the world, and those come from southern Africa. Then we go into the mountains of the Cape supergroup, the folded mountains on the way down to Cape Town, and we find there a remarkable history of invertebrate animals and fishes. And there's a history of fishes that's only just beginning to come out, and I'll talk a little bit about that. Then we move over to the Karoo at about 300 million years ago, and it has an unsurpassed history of the development of reptiles on Earth and the origin of mammals. So you can see we're not at humans yet. Humans come a little bit later. At 180 million years ago, Gondwana breaks apart, southern Africa separates from the rest of the world, or Africa separates from the rest of the world. There's not much of a deposition history in South Africa. And then, in the end, at about 3 million years ago, in these cave deposits in the cradle of humankind, what Lee's going to be telling you about, we've got a remarkable story of origins. So human origins come from 3.5 billion years ago, but go through many stages along the way. If we look at the origin of life in Barberton, that's what life started as, primitive blue-green algae and microscopic organisms. Then we jump a couple of billion years to the Cape supergroup, these folded mountains that we see on the way down to Cape Town, and you could see this early fish from there. This is an early jawless fish. It comes from near the Cedarburg, and you can see the eye, the backbone over there. We still have modern jawless fish today. They are the most primitive of fish, and you could see in the modern lamprey, which has a sucker and a rasping tongue around a mouth, and it simply bores its way into its prey and then sucks out his juices, I suppose, is the easiest way to term how it lives. And Dr. Robert Guess, who was a student of mine a couple of years ago at Wits, discovered this remarkable fossil down at Grahamstown. Now, I know that our listeners can't see this, but if you look closely at this, it's a little fish, the length of your first digit of your thumb, and the front is an oral sucker, and there's some gill slits over there, and this is the oldest fossil lamprey in the world. It comes from Grahamstown. Some people might say then Grahamstown has the oldest parasites in the world. Then we move into this paleontological wonderland, and that is the rocks of the Karoo. They cover 2/3 of the surface of South Africa, extending right from Laingsburg up to Gauteng. And what is important about them is they cover a history from 300 million years ago in the oldest rocks to 180 million years ago in the youngest rocks. So they cover a history of about 120 million years. And it's largely unbroken. And because these rocks are very full of fossils, we can chart the development of life of the various types of fossils found over that extended period, particularly the reptiles. Do you want me to do something?
Professor Rubidge, sincere apologies. We're just swapping mics
Okay.
because we have...
Does this one work better?
It's not very audible.
Does this one work better? South Africa has a remarkable history of reptile origins. Now, modern reptiles fall into 3 groups, depending on the number of holes you've got in your head behind your eyes. So if you've got no holes in your head behind your eyes, then you're an anapsid. If you've got 2 holes in your head behind your eye, you're a diapsid. And then modern diapsids include lizards and snakes and birds and dinosaurs. Dinosaurs being not modern, but being represented by birds, which are really living dinosaurs. Is that okay? And then the synapsids, which have only one opening behind the eye. And mammals belong to that, and we are all synapsids as well. Are you happy with the sound now?
Yes.
So all of these lineages originated in the Karoo in South Africa. We have the anapsids, the diapsids, and the synapsids. And the time of deposition from the Karoo was from 300 million years ago to 180 million years ago. And this whole diversification of all of these different groups occurred or is recorded here in South Africa. Looking at the first group, the anapsids, the tortoise ancestors, this little creature with its very broad ribs is considered to be the most distant ancestor of tortoises. It was considered that way in the early part of the century when it was first discovered, but many scientists did not agree with it. Can you hear me now? I hear feedback the whole time. And more recently, with the aid of these 2 American scientists, Tyler Lyson and Gabe Beaver over there, who've joined our group of scientists working with us in the Karoo, we've established that this is actually the most distant ancestor of tortoises known, and that's by looking at various embryological features of modern tortoises and comparing it with this fossil one. On the dinosaur line, in the Eastern Free State, we have a remarkable history of dinosaur origins in the Golden Gate sandstones and the red mudstones below that, some of the oldest dinosaurs known in the world. A couple of years ago, Professor James Kitching, who worked here at Wits University for more than 53 years, discovered a nest of eggs near Golden Gate, with a little dinosaur embryo preserved in one of them. Those are the oldest dinosaur eggs in the world. More recently, working with scientists from the University of Toronto, we found another nest of eggs, this one with 28 eggs preserved in it. Those in the audience here can see this wonderful nest of eggs preserved over here. There's the mommy of these baby dinosaurs. And current research being done at the moment by our students at Wits University and by Dr. Jonas Schwannier, by scanning the bones of this thing, we've been able to look right into the structures inside the bones and also the brain cavity of this dinosaur. That's the picture. The oldest dinosaur in the world looking after her little babies. And we've actually found the footprints of the babies around those nests as well. just an exciting development this year. Dr. Jonas Schwanne here doing an excavation near Maclear, where he found this new species of dinosaur, the hand just being exposed earlier this year. And I think watch the space for what happens in the future. But then the line that I want to actually tell you about is the line leading towards mammals, of which South Africa has the richest record in the world. This one that you see on the screen in front of you, with all these different teeth, is a Gorgonopsian. This is our most distant ancestor from the Karoo, aged at about 260 million years old. It's a flesh-eating animal, but there were plant-eating animals as well, and completed a whole ecosystem in that time. And right at the top of the Karoo succession, we have the earliest mammals known in the world. This little one called Megazostrodon, which is only the size of your thumb, is the oldest mammal known in the world. This particular one is on display at Origin Centre here at Wits University. So what is the picture that we get out of the Karoo? We can follow by following from the earliest rock layers in the Karoo right up to the youngest layers. We can follow the course of evolution of the different ancestors leading towards mammalness. And just one characteristic that we can look at is that mammals have a hard bony palate. You and I all have a hard bony palate that separates our mouth from our nose, so we can breathe and chew at the same time. Reptiles don't have a hard bony palate, and in the slide that you've got in front of you, the palate bone is that red bone over there. So as you travel through the Karoo, the palate bone gets broader and broader and eventually forms in the middle, as in the mammalian situation. This is a wonderful history that's documented in the country, and there's no other place in the world that has a history so complete of the origin of mammals and ourselves. Some exciting things that come out of these Karoo rocks. Dr. Meryl van der Walt recently completed her PhD on creating a GIS database of all the fossil localities and the fossils from the Karoo. And now, using this information, we can look at the distribution of these different animals throughout the Karoo. And we've got now a map showing the distribution of different species. So the different colors that you see in the map in front of you is the distribution of different species of animals that have lived in the past, but over a long time period, starting over here at about 280 million years, going to 180 million years over there. And now what is important about that is, at that stage, South Africa was linked to all the other countries of the world. And so this has global applicability. But an exciting development just in the last year is that we've found volcanic ashes with each one of these zones, and we've been able to date them and put a date onto each one of these zones. So, and the dates you can see are remarkably accurate when you consider the time period. This date, the oldest date that we've got over here, 261.275 million years, plus or minus 0.02 million. I think it's remarkable accuracy for that length of time. And it's the first time that these different zones in the Karoo have been dated. And because we were linked to the other countries of the world, other countries of Gondwana at that stage, we can now use this information to date other rock sequences right around the world as well. But the other exciting part of this development is that we can actually now work out the tempo of evolution, of how fast evolutionary trades happen through time. And this is a major scientific breakthrough. Just an exciting little thing that we discovered last year. We've been looking at fossil burrows. Now, a burrow is a hole in the ground, but if you want to preserve it as a fossil for millions of years, the only way you can do that is by filling the hole in. And so, if a flood brings in a whole lot of sand or mud or something, then you can fill that and create a plug. And here you can see at Colesberg, we're excavating one of these fossilized burrows going down here. When we took it out, it had a spiral shape going down to the bottom. The bottom was the terminal chamber. And in that terminal chamber, we found some bones. And then we scanned those bones with the synchrotron in Grenoble in France, and we found there, in that burrow, 2 complete skeletons. of a little mammal-like reptile lying there, curled up, and an amphibian lying next to him. The sort of picture we get from that is the burrow, a mammal-like reptile lying in the bottom, and an amphibian coming to join him. This happened 250 million years ago, 252 million years ago. We can talk about how they came to be in the burrow together. They're completely different species. A major discovery is that in the last 500 million years, scientists, paleontologists have recognized that there have been 5 major extinction events. That species go extinct at an extraordinary fast rate. And anything from 65 to 95% of species go extinct over a relatively short period. One of them occurred here at 450 million years, one at 370 million years. In the Karoo in South Africa, we have one at 252 million years, and another one at 200 million years, and then the one that whacked out the dinosaurs 65 million years ago. 3 of those extinction events occur and are well represented here in South Africa. And I want to tell you a little bit about development that we've got, which shows up another extinction event. This is a group of people that have been working with me in the Karoo for the last 30 years. We've been collecting fossils all around the basin in South Africa. These are the rocks that we're looking at, and we're looking particularly at this interval here. But we're looking at a 2-kilometer section of rocks, and we've measured these around the basin. My postdoctoral fellow, Michael Day, has done measured stratigraphic sections right from Grahamstown, Prince Albert, Laingsburg, up to Sutherland, and up to the Free State as well. And when he's done that, he gets a whole lot of logs that look like this. And on those logs, which are 2 kilometers long, he then plots all the different fossil localities and the fossil horizons that come out of that. And from that, we've discovered that at a certain point in that measuring up sections from, I don't know what I must do now.
We are having a bit of a problem with our sound in the lecture theatre tonight. Sincere apologies about that. We're going to take a short break and try and sort it out, and then continue with our lecture series. Our guest is Professor Rubidge, and he was talking about humanity's origin.
Well, I'm nearly going to go that one. I'm nearly finished in any case. And what we found is that at a certain point in the stratigraphy, suddenly the number of species of animals.
May I ask you to just pause for a minute?
Yeah.
We've got spots in the air at the moment, and then as soon as we can.
Go to telcom.co.za or visit your nearest Telcom store. Conditions apply.
Are you aware that every time you buy mobile products, you are entitled to free, simple information in a language that you understand? Mobile
The Minister of Science and Technology, Derek Hannebaum, will host ministers of the SKA Africa partner countries for the launch of the first meerkat antenna on the 27th of March 2014. This launch also forms part of South Africa's 20 years of democracy celebrations.
So you can do what you're doing at your own home.
Pay a visit to the leader in fixed broadband. Call 10213, go to telcom.co.za or visit your nearest Telcom store. Conditions apply. The Talk Shop.
This is The Talk Shop, and we are broadcasting from Wits University. We're at the National Research Foundation's Science for Society lecture series, and tonight we are looking at the issue of the origins of humanity. The question we are looking at is Palaeoscience charting the course of humanity's past. That is the issue on the table tonight, and we interrupted Professor Bruce Rubidge, Director of the NRF DST Center of Excellence in Palaeosciences and Interim Director of the Evolutionary Studies Institute at the University of the Witwatersrand, looking at the origins of humanity, and he is going to just continue and quickly wrap up. Professor Rubidge.
Thank you. So where we got to was we looked at the whole development of life on Earth up until about 250 million years ago, and with Karoo rocks. And I was pointing out to you that there had been several extinction events in the world, and that we've discovered a new one which occurs at about 260 million years ago. Because of volcanic ashes, we've been able to date it, and now we are looking at where the different species actually disappear and how long it takes for an extinction event to take place. And that is going to be groundbreaking news, and it's a thing for the future. So as I end, I want to just end with the words of Tom Barry and Mike Kluver, who were two famous paleontologists from South Africa, who said South African paleontology is world paleontology, and the research workers of this country who are involved in it have an important duty to ensure that their unique heritage is in their charge is never threatened by neglect, but preserved, recorded, and ultimately reconstructed to serve as a standard world guide to the extinct animals of the prehistoric past. Thank you.
Thank you very much, Professor Rubidge. Professor Bruce Rubidge was looking at humanity's origin, looking at the origins of Earth, talking about Barberton, the Cape Supergroup, and of course the discoveries made in Grahamstown, as well as the rocks of the Karoo. We're now going to move forward, and we are giving the space to Professor Lee R. Berger. He is currently a research professor at the Evolutionary Studies Institute and an advisor for the Center of Excellence in Palaeosciences at the University of the Witwatersrand. He is an award-winning researcher, explorer, author, paleoanthropologist, and speaker. Professor Berger is a founder of the Paleoanthropological Scientific Trust, the largest non-profit organization in Africa, supporting research into human origins, and is a founding trustee of the Jane Goodall Society of South Africa. He is a fellow of the Royal Society of South Africa, an explorer in residence at the National Geographic Society in Washington, D.C., and director of one of the largest paleontological projects in history, leading over 100 researchers in investigations of the Malapa site in South Africa, where a new species of early human ancestor was discovered. He'll tell us more about Australopithecus sediba. Prof?
Thank you very much, and it's a pleasure to be here this evening. My colleagues and I are in the middle of one of the most extraordinary periods of discovery and exploration that perhaps has occurred in the search for human origins on the continent. But before I tell you about that and share some of the exciting finds that are going on, I want to take you back a little bit to look at the history of the search for human origins on the continent to place in perspective just what is happening to this science during the period, during the first and second decades of the 21st century. This is in fact the 90th anniversary of the discovery of the Tong Chow. In 1924, Raymond Dart from Wits University found the first fossil that would be described as an early human ancestor, although it takes several decades to be accepted, and that would start the search for humankind's origin, a search that was predicted by Darwin in The Origin of Species in the continent of Africa. Up until 1948, finds that would occur in South Africa at sites like Sterkfontein and Swartkrans and Kromdraai, led by people like Robert Broom as well as Dart and others, would lead the search. All of the attention was focused down here in southern Africa. But in 1948, the National Party came into power. And perhaps human origins and the evolutionary understanding that we all stemmed from one common ancestor on the continent of Africa was perhaps not popular with that sort of political ideology at that time. And research funding and research support for the search for human origins in southern Africa actually began to become quite minimal during after that into the 1950s. But great things were happening elsewhere. And by the late 1950s, Lewis and Mary Leakey started an explosion of research in Eastern Africa. At sites like Olduvai Gorge in Tanzania, they would find other early human ancestor fossils, and they would proclaim that East Africa, in fact, was more likely the source of the origins of humankind. And that would begin to propagate a quite veritable explosion in scientific exploration and discovery through countries like Ethiopia, Kenya, and of course also in Tanzania. By the late 1960s, countries in Ethiopia, and particularly Kenya around the Kubi-4 area, led by their son Richard Leakey, began to give us fossils that were quite extraordinary, not only in their morphologies, but also in their numbers. We were starting to move from dozens of fossils. Until that time, this fossil record of human origins in Africa had been considered one of the rarest records of any fossil family that exists. But in Eastern Africa, you started to see more and more, quite literally hundreds of fossils began to be found in these lake sediments and in these riverine sites where these explorers were finding these fossils. By the early 1970s, Ethiopia began to deliver not just fragments of fossils, but skeletons of fossils, with the first true skeleton of a fossil, the famous Lucy fossil, being discovered by Donald Johanson and his teams in the Hadar of Ethiopia. And by that time, by the middle of the 1970s, moving into the late 1970s, it had basically been firmly established in the minds of many scientists, and perhaps the public at large, that the story of human origins was an East Side story. That it was not a story that had occurred here in southern Africa where those first fossils had been found. This was in fact probably a side branch, and continued explorations, largely in those three countries that I mentioned, would lead to more and more fossils being discovered and more evidence that would point to the critical events in human origins happening along the Eastern Rift Valley, up into the north of Africa, into the highlands of Ethiopia. And that would give us a story of the origins of bipedalism, at back 3, even 4 million years. That would give us the origins of the genus Homo, the expansion of our brain, sometime 4 million years. All these critical events that identify us as this remarkable animal out of Africa. By the late 1980s, there was almost no work going on here in southern Africa except for being held by a couple of brave researchers, people like the late Professor Philip Tobias and Professor Bob Brand at the Transvaal Museum, who were carrying on research at a couple of core sites. But it did not receive the kind of attention those East African finds did. By the early 1990s, though, I think as we're all aware, things began to change in southern Africa. The search for human origin began to get support once again, particularly by the middle 1990s, and small discoveries began to get made. Discoveries like the site of Gladysville, which my team and I made back in 1991, which was the first new early hominid site to be discovered in 1948. By the time we reached the late 1990s, smaller sites had yielded more and more fossils, and we began to see bits and pieces coming from some new sites. By the end of the by 1998 itself, we saw the discovery and description of the first skeleton that had been discovered truly in southern Africa, that of Littlefoot. But that came from a site that was very, very well known, a site called Sturtfontein. And there began to be an idea still pervasive in our field that we've discovered it. That most of the major discoveries had already been made, and that this was an ever-depleting resource. Still, the East Side story of human origins dominated as we moved into the 21st century, with the idea that those critical events were still coming out of East Africa. And the fossils that were coming out of southern Africa were in part largely sideshows to that, mostly evolutionary extinct dead ends. In 2008, I discovered the site of Malapa, and on the second visit, my then 9-year-old son Matthew discovered the first piece of a hominid that would launch the Malapa project, one of the largest projects in the Palaeosciences that had ever been launched. Today, with over 125 scientists and researchers from around the world examining the remarkable fossils from this site just outside of Johannesburg in the cradle of humankind. From that site would come a number of skeletons, a rich fossil deposit, making that little tiny site that we discovered one of the richest early hominid sites in the world. Almost unprecedented levels of preservation and discovery. We would name a new species, Australopithecus sediba. And that research and project would launch sort of the idea that there was more to discover out there. Because it's important to remember that this area outside Johannesburg had been searched almost continuously since 1935. And yet here in the middle of it, right next to some of the major sites, was not only just another site, but perhaps one of the richest that had ever been discovered. We spent the last 5 years publishing that in a number of scientific articles and doing research on these remarkable specimens. But I think in the back of our minds, we did think that we had sort of hit the jackpot. That that was going to be perhaps the biggest find that we would ever make. That is until last year. In October of last year, my teams who were out in the field exploring brought me some photographs of a remarkable series of fossils. The fossils were found in a site right under our nose, less than a kilometer away from the site of Swartkrans that had been worked since 1948, and just over a kilometer away from the site of Sturkentain, the oldest continuous dig in the history of paleoanthropology on the continent. And in that photograph were remarkable fossils. That launched an expedition, which we launched in November with the help of amateur caver societies, as well as these becoming professional teams, as well as explorers from around the world who joined us. And in a short period of 16 days underground in November, in what was then called the Rising Star Expedition, we recovered the largest assemblage of early human ancestor fossils ever discovered in history. 16 days, we discovered 1,200 early human ancestor remains. And to place that in perspective, that is more hominid fossils, more human ancestor fossils than been discovered in the last 90 years in South Africa. Our teams are underground right now, literally today. I just came out of the ground this morning, where we're pulling out more fossils from this remarkable deposit, and there are more discoveries to be made. We've discovered other fossil sites like this. And the reason we've done that is because we got back out in the field and began exploring again. And that's the message that I want to leave the audience with tonight. We thought we were a field that by the early 21st century thought it had discovered everything. We thought that there were no new finds to be made. We were a field that sought perhaps the rarest sought after objects on the planet and had convinced ourselves of their rarity and thus that we wouldn't find them. And so I would dare say that some of us stopped looking. The fact of the matter is, though, that they are out there. That we have a record in Africa of human origins that's unrivaled. That here in southern Africa, we have a record now that's unprecedented, perhaps in archaeology, paleontology, and paleoanthropology. And our teams are fast making these once rarest sought after objects on Earth the not so rarest sought after objects on Earth. And that's something that I hope everyone hears, particularly young people, because I think there is a tendency in the community, particularly children, to think that all the great discoveries have been made. That the great ages of exploration were 100, 200, 300 years ago and were done by sailing ships and people who would land on lands that they thought might be unoccupied but weren't, and claim them and find new things, and that every mountain had been climbed and every great thing had been found. But that simply is not true. And actually the search for human origins here in southern Africa, run out of this university by some amazing people, is showing that we have not seen this planet. We have not found everything. Because right under our noses are great things to be found. The site of Malapa was so easy to find that a 9-year-old could do it. These new sites like Rising Star are sitting directly under the most explored cave sites and fossil sites in the history of this science, lying right on the surface, and all it needed was a photograph and brave people to go and look for it. We are going to enter a new age of exploration, and that age of exploration is going to be led by developing world countries like South Africa, countries in Africa, Asia, China, who have these resources and can lead this sort of adventurous exploration. As I end now, I just want to note for both the audience here and the audience on the radio that there's some extraordinary people in this room that I want to point out. Some of those very explorers, the ones who actually made the discovery, two of them are in this room, Steve and Rick in the audience, as well as some of the remarkable young women who led the expeditions to recover those fossils back in November, what I would call underground astronauts, Maureen and Beck. I'd like them to stand, as well as the other members of the scientific team, just for a moment, because these people risked their lives to find these extraordinary... heroes of the next generation of exploration, delivering to us this extraordinary story about where we come from. Thank you.
Professor Berger is a research professor at the Evolutionary Studies Institute and an advisor for the Center of Excellence in Palaeosciences at the University of the Witwatersrand. Very interesting when he says that this information is so easy to find that a 9-year-old could do it. A 9-year-old did do it. And when one looks at the discoveries since then, it is absolutely mind-blowing. We're going to take a short break, and when we come back, we're going to open up the floor for our question and answer session for our audience here at the Lecture Theatre at Wits University. And for you at home as well, you're very welcome to engage with our two professors on 0891 104 207, 0891 104 207, or SMS 34701. SMS number is 34701, and SMSs are charged at R2. We're at the National Research Foundation's Science for Society lecture series at Wits University, and the title that we are looking at the issues tonight is Palaeoscience Charts, the Course of Humanity's Past. And don't forget that the first presentation was made by Professor Bruce Rubidge, Director of the NRF DST Center of Excellence in Palaeosciences and Interim Director of the Evolutionary Studies Institute at the University of the Witwatersrand.
This week on Justice Prevails.
You love my daughter. That's what you want to tell me, isn't it? You said that I was the only woman for you.
You forced me to say that even. You trapped me into sleeping with you.
I trapped you? What makes you so special?
Man about the house.
You're going to wish that you'd never met me or my daughter. 2 shots, one in the head, one in the chest.
Justice Prevails. On Sunday afternoon at 3:30 on SAFM.
SAFM is giving you, our Cape Town-based listeners, a chance to receive double tickets to this year's Cape Town International Jazz Festival at the Cape Town International Conference Center on the 28th and the 29th of March. To stand in line to receive these tickets, SMS the keyword jazz and your name to 34766. SMSs cost you $150. Free SMSs do not apply. Please note, this is a one-day pass only. SAFM and all that jazz.
The Talk Shop.
The Talk Shop is looking at Palaeosciences tonight. Palaeoscience charting the course of humanity's past at the National Research Foundation's Science for Society lecture series at the Senate House complex at Wits University. We've got a studio audience here, and I'm sure you heard Professor Berger acknowledging his team, some of the team that he works with. We will try and get them to just tell us a little bit about some of the discoveries that they've made. No. One of the members is going, no, silently. We're all fascinated, and just your perspectives would really be appreciated. We'll do that a little bit later on in the second hour of the talk shop tonight. And we've got an audience here in the lecture theatre that is very keen to be asking questions to our two guests, Professor Bruce Rubidge, the Director of the NRF DST Center of Excellence in Palaeosciences and Interim Director of the Evolutionary Studies Institute at the University of the Witwatersrand, and Professor Lee R. Berger, Research Professor at the Evolutionary Studies Institute and an advisor for the Center of Excellence in Palaeosciences at the University of the Witwatersrand. Now, a lot of jargon was used tonight, and I think we need to just look at opening up some of the points that were made during the presentations by our two professors. I'm going to kick off with you, Professor Rubidge, and talk about the 5 extinction events that you spoke about, and you said that we could be in the 6th extinction event, and one has to ask, what brings about these extinction events? And how are we as humans contributing to them?
I think that that's one of
yes.
I think that that's one of the things that we are really trying to find out. And the only way that we can come to understand our current extinction event and where it comes from is to go and look at past extinction events and try and understand what causes them. And there have been lots of theories of extinctions, why dinosaurs went extinct. But I think the only thing that is coupled, or only event that is coupled with every extinction event is a period of a lot of volcanic activity in the world. Every extinction event is coupled with a period of volcanic activity. And that could lead to lots of things. It could lead to earthquakes, it could lead to gas clouds, it could lead to carbon dioxide buildup, it could lead to all of those sorts of things, which could lead eventually to environmental catastrophe as well. And I don't know, just a couple of years ago, you recall that all those aeroplanes were grounded because of volcanic activity in Europe, and that's just a small indication of what can happen with a lot of volcanic activity around. And I think that's one of the exciting things about extinction events, and studying them in the past, is to try and work out how long they take. What length of time does it take for animals to go extinct? Is a short period 200 million years? Sorry, 200,000 years? Or is it 20,000 years? Or is it a day? Those are the sort of questions we're trying to answer, and we don't have the answer for that.
And what about the animal's ability to adapt to these extinction events? And I think currently there's a lot of talk and speculation that we are in the 6th extinction event, and the question has to be asked, what does it look like in the future for humanity?
Well, I think that extinctions are triggered by animals that can't survive changing climatic conditions. And that is really what the determinant. Those that can survive changing climatic conditions or changing environmental conditions can continue to survive. And if humanity can't adapt to changing environmental conditions, then we won't survive either. But humanity is different because we are able to change the environment ourselves, and we are able to change things to a certain extent.
I want to talk about that in light of the current climate change concerns and the obvious climate change effects that we're seeing. So we'll talk about that in the next hour. I just want to bring Professor Berger in. Professor Berger, you spoke about the East Side story and the impact of these discoveries in Eastern Africa. You spoke about bipedalism and how, and the evolution, genus Homo. Just break that down for us, please.
Okay, well, the East Side story was an argument that all the critical events in the origin of humanity have been driven by the rifting of Africa along the Great Rift Valley, on the Eastern Rift Valley, and also in places like the Middle Awash and Hadar in Ethiopia. What we're now finding is the story is much more complex than that. That in fact, perhaps even some of these new discoveries are saying that what's happening down here is equally informative, if not perhaps more informative in some areas around certain events, and that perhaps the story of human evolution is more complex than a single regional event, but it may have occurred across the continent in very different areas. What I can guarantee you we found out is we actually didn't know very much about what was going on at all. We thought we had it figured out. We thought we had a straightforward, simple story that's anything but simple. And certainly these new discoveries coming from Southern Africa are that. Now the term bipedalism is a very important one. I use the term hominin as well. What that is bipedalism is one of the characters that's walking on two legs. that we use to separate out both us and our ancestral lineage. We're the only mammal that habitually walks on two legs on the ground, uses it as our primary form of locomotion. So it's a very critical one. Hominins are just animals that walk on two legs that are in the family tree of humankind.
So we'll be hearing more about Australopithecus sediba, because I understand that really explores not only the spine and curvature and what it means for the origin of man, but also the hand as well. There's a lot. We're going to be discovering a lot tonight. Of course, as I said earlier on, we are at the NRF's Science for Society lecture series at the University of the Witwatersrand. We had a bit of a bumpy start with regards to sound, and we do apologize for that, but we are flowing now, and that's what happens when you're out at an OB and outside broadcast, and it is thrilling, I will tell you that. The theme tonight is Palaeoscience Charts the Course of Humanities Past, and our guest speakers are Professor Berger, Research Professor at the Evolutionary Studies Institute and an advisor for the Center of Excellence in Palaeosciences at the University of the Witwatersrand, and we'll also have Professor Bruce Rubidge, Director of the NRF DST Center of Excellence in Palaeosciences and Interim Director of the Evolutionary Studies Institute at the University of the Witwatersrand. I'm looking at some of the questions that are coming through from our audience in the lecture theatre tonight, and I will tell you that they definitely know so much more than I do, and I'm sure you do. So we're all at sea here, and we're here to learn. This is a learning experience for all of us and an information sharing experience. And we will be taking your calls on 0891 104 207 a little bit later on. That's 0891 104 207. Or you can SMS us on 34701. SMS number is 34701, and SMSs are charged at R2. And of course, don't forget that a little bit later on, we've got the news coming your way with Greg Post, and after that, we will then be exploring the different ideas that are flowing here in the lecture theatre, and of course, taking your calls and SMSs. We're back after this.
The best of the African connections, Richard Mwamba, the dance edition, continues to make lovers of African music dance. Get your copy of the best of the African connections, Richard Mwamba, the dance edition, at your favorite CD shop or online.
Hi, I'm Zolani Maola. You're listening to SAFM. Remember to catch Sharp Sharp Children's Show on Tuesdays and Thursdays. Keep it sharp sharp.
Hi, I'm Ezra Ryan, the founder of the Big Break Legacy. Want to find out how to start a business or how to run a successful business? Learn how to be that successful entrepreneur? Tune in to Money Makers on Afternoon Talk every Wednesday between 2:30 and 3 p.m.
The Talk Show.
The Talk Show on SAFM 104 to 107, coming to you live from the National Research Foundation's Science for Society lecture series at the University of the Witwatersrand. The theme tonight is Palaeoscience Chart the Course of Humanities Past. When we come back, we will be taking some of the questions in the lecture theatre and, of course, engaging our guest speakers. Time now for the news with Greg Post.
SAFM, South Africa's news and information leader.
Zuma hits back at opposition parties and the public protector reacts to ANC comments. Good evening, I'm Greg Post with the news on SAFM. President Jacob Zuma's lashed out at opposition parties that accused the ANC of making false promises. He was addressing thousands of people in Kimberley in the Northern Cape as part of the ANC's election campaign. Earlier, Zuma addressed local business people and asked them to vote for the ANC. He says detractors are the ones who are making false promises because they have no record of governance.
Thank you very much, ladies and gentlemen. Competing with the president. I would like to invite Dr. Tamotz to just pass these tokens of appreciation in this time so that when they respond to questions, however difficult, they may feel encouraged.
Again, our client is Samantha. Our clients are
for answers and accepting the resignation, controversial officials from their birth of his president Germany, Bishop of suspended on his duty last year, as followed now with criticism of such money spent on work in his official residence.
Working his own private order as a gentleman, costing £4 million. His class alone emerged as a store of media attention and angry demands in Germany that they should not dismiss.
Old story, President Jacob Zuma's lashed out at opposition parties. They accuse the ANC of making false promises. Next news bulletins at 9 o'clock.
The Talk Shop. This is the Talk Shop, and we are at the University of Witwatersrand. We are at the NRF Science for Society lecture series. The theme tonight is Palaeoscience charts the course of humanities past. And our speakers, Professor Bruce Rubidge, Director of the NRF GST Center of Excellence in Palaeosciences and Interim Director of the Evolutionary Studies Institute at the University of Witwatersrand, and Professor Lee R. Berger, Research Professor at the Evolutionary Studies Institute and an advisor for the Center of Excellence in Palaeosciences at the University of Witwatersrand. You are listening to the Talk Shop on SAFM 104 to 107, and I am Masechaba Dolo. We've got a couple of questions coming through from our audience in the lecture theatre tonight, and we'll also be engaging some of the team working with Professor Lee R. Berger. He was telling me during the news that they go down, it's absolutely fascinating, they go down and these thin tunnels and try and extract this information so that we can learn from it and move on and explore what it means for us as a society today. I wanted to talk about what the discovery of 8 Sidiba means and how it differed from previous discoveries. And then after that, we'll also be talking about climate change and what it means. Are we going towards another extinction event, as articulated by Professor Rubidge earlier on? Just quickly, Professor Berger, tell us about the discovery of A. sediba and what it means.
Well, I'll start with Pithecia sediba, which was discovered in 2008, and we described for the first time in 2010. Has been a very surprising species to early hominid paleoanthropologists because it was completely unexpected. It didn't fit within the sort of storyline of the fossils that we were developing. It showed a lot of what we call mosaicism. It had a very small brain, but a well-developed brain, a very advanced brain. It had small dentition, but with dentition that had some characters of more modern species like Homo erectus or even Homo sapiens, but other aspects that looked very, very primitive, as if it came from something deeper like an Australopithecine. Had long arms that if you had seen them alone, you would say were for climbing, but on the end of it had these remarkably derived hands that you could mistake in some way for our own hands. The thorax was shaped like an 8, the chest was shaped like an 8, the spine was intermediate between a very primitive spine and a spine like ours, yet it walked on 2 legs just like you and I did in the pelvis structure and in the lower limbs, but the feet were odd. The back of the feet looked like a chimpanzee, the front of the feet looked like our feet. So it was this very unusual mosaic collection of features that were completely unexpected based upon the fossil record we had previously. However, having said that, it was also one of the most, in fact, still is, perhaps the most complete early hominid skeleton ever discovered. So some of the questions arise were we misinterpreting the fragmentary record, and now we're seeing what some of these things really look like from head to toe, or is it that different? Those are some of the exciting things that the new discoveries coming out of Southern Africa are helping to answer.
And with regards to climate change, Professor Rubidge, we're all very aware of global warming, of greenhouse effects, and where we're going with the melting of the ice. And one has to ask the question, are we in another extinction event? And if we are, what does it mean? I know that there's a lot of debate about whether it is currently underway or not, but you have mentioned that we are looking at extinction events happening closer and closer together. So that must mean that, where are we going? What does that mean for us today?
I think that I would start off by saying that I'm a specialist in the past, not a specialist in the future.
Okay, looking at the past and what's taking place. I'm sure we've all seen Ice Age, no?
So I think to ask me where we're going is not what I am geared up to do. I can tell you what we observe, or what we think we've observed in the past, and by looking at past extinction events. And I think what I was trying to say in my talk was that we've discovered another extinction event in the Karoo, which was happening and recorded in life on land 260 million years ago, whereas they also found an extinction event in China that occurred in the sea 260 million years ago. So what we're trying to do now is to see how the correlation occurs and to use the good and very precise dating that we've got in these rocks to work out how long extinction events last for and how long they take to happen.
I think, do you want to come in there?
Yes, I also studied the past. I also study a particular animal that's involved in the past, and that's humans, and their origins. And in fact, I would argue that we are in this extinction right now, and it's not being driven by climate change, interestingly. It's being driven by us, and we're driving climate change right now. The fact of the matter is that we have become, in a remarkably short period of time, literally the last 2 million years, but particularly in the last several thousands of years, an extraordinary species that has occupied almost every terrestrial, in fact, every terrestrial habitat on this planet, and perhaps some aquatic habitats as well. We are one of the most populous large mammals on this planet, and we are devastating to it. We are causing an extinction event in the tropical rainforest, in the savanna, everywhere we do, either through our very presence, our ways of destroying these environments to make them more habitable for us, and species are going extinct at unprecedented rates. Climate change is a factor of us altering our habitat to suit our environment. Population overgrowth is causing this climatic change, as well as the extinction of the animals we share this planet with. So we are in a sixth extinction, I think. I think many of my colleagues would agree to it. And as I said, it's not being driven by climate change, it's being driven by us, and in part, us driving climate change.
And that is the whole purpose of studying the past, is it not, in terms of what can we learn from the past to guide us today in how we interact with society, how we interact with our planet.
Absolutely. A geologist named James Hutton coined the phrase, the present is the key to the past, and as you state, the present, we understand the past is also the key to the present and the future. It's how we understand processes and effects that went on before us in the real world. The past is real, and what it means for us right now and what it means for us in the future. Believe it or not, paleontology, despite what some people think, is an applied science.
Okay, there you go. I've got a couple of questions coming through from our audience here in the lecture theatre. Marcus Burns asked the question, can the mammal paleontologists say they have found everything?
I think that that's a very nice question to answer. Because as Lee says, we're only just beginning to find things. And I think the exciting thing about field work to us is that every time we go out, we find more fossils and more species. And Lee has mentioned that he found Australopithecus sediba, and now he's got some exciting news and stuff that he also shared with us a little bit. I pointed out in my lecture that Jonah has found this new type of dinosaur, Jonah swannier, and every time that we go out into the field into Karoo, we find new species of animals that we've never found before. So it's a thing that goes on all the time, and that's what makes our work so exciting. And I think that because we've got such a remarkable record in South Africa of the history of mammalian evolution, every new species that we find fills a new, to coin an old phrase, a new missing link, or a new gap in the evolution of mammals.
Another question, this one is coming through from Ryan, and Ryan asks, please tell us more about the fossils you found in the Rising Star expedition, and could you determine if there were any children from the fossils? And Ryan is age 11. Is Ryan here in the theatre?
There's Ryan in the back. Hello, Ryan.
There's Ryan. Ryan is 11 years old, and he wants to know the children that form part of the fossils.
What a fantastic question, Ryan, and I'm going to do a terrible thing to you at 11 years old. I'm not going to answer your question. Right now, this is a very new discovery, and we're assembling an incredible team of scientists. In fact, in May, a workshop sponsored by the National Research Foundation will be bringing together one of the largest assemblages of early career scientists and mentors from my team to study these fossils. There are two things that we can deal with now: the facts of the discovery we made, and where we won't go, and that's the speculation around the fossils. To establish things like whether there are children or the age of these fossils takes scientific research. And so I don't want to speculate right now too much on the ages and such. What I can tell you this is the facts. We have found a remarkable assemblage of hominids, the largest ever discovered in history. They have, I'll tell you this, the morphology or the features, the physical features of what we would describe as an early hominid. They do not appear, they're not us, and they're not something right near us. There's something that would appear to be more primitive than us. And that's about where I'm going to stop. All right. Watch this space, though, because with the help of this university, places like the National Geographic Society, and places like the National Research Foundation, we're changing the way we do this science. You used to have to wait perhaps decades to hear about these discoveries after we discovered them. With Sediba, we did it in 18 months. We're going to do that even faster now.
And with Sediba, I understand that you had Garabo, and you also had some.
We do have infants. There are children. There are infants there. From Malapa so far, we have at least 6 different individuals coming Of that, we have a young boy that's just a little bit older than Ryan up there in developmental age, and that's Carava. That's the one we ran in that national competition for school children to name. Then we have a female, an adult female that's substantially older than Carava, but you never ask a woman her age, and we can't determine it anyway right now. Then we have a couple of infants, some very, very young ones. We haven't extracted them from the ground yet, so I don't know exactly how old they are. And then there's a couple of other adults. Those are still under study too, and we actually begin the excavations in Malapa within the next 4 to 6 weeks, which should reveal some extraordinary things from that side.
Absolutely, wow. I hope you answered Ryan there. Yeah? Okay, great. I've got Clinton Kingma, who joins us here in the theatre.
This is great day. I'd like to know, is it possible that a large portion of hominid fossils are embedded in the ocean? And if so, how would you know that?
So, whether the fossils are embedded in the ocean is an interesting question. With human origins, we're dealing largely with relatively recent times. That is the last, say, 4 to 5 million years. That's recent in our terms. You get to older times when you do the kind of times that Bruce has. The ocean is a very destructive environment. As you're quite correct to point out, probably where you're alluding to, that sea levels rise and lower over time, and sometimes what is now ocean has been land and had the potential for occupation. But it's also a very destructive force when it moves over those lands and often destroys terrestrial fossils if they existed as it moves over them. But the answer is, quite simply, we don't know. And that kind of exploration hasn't been conducted, and it should be. We should have people not only exploring the terrestrial environment, the subterranean environment where we're working, but also the marine environment as well. The coast of South Africa is a wonderful place for that. 100,000, 200,000 years had an extraordinary large coastal plain, and we have quite a lot of evidence that very critical events occurred in the origin of our species along the coast of southern Africa. And there could very well be very important evidence for out there. We need people, we need explorers, young people, going into the fields of science and going into the fields of scientific exploration to answer the question, because I can't, because we haven't done that work.
All right, a question that's coming through from Moses Mbofu here in the lecture theatre tonight. He's a computer science student at Wits. He asks, what kind of technology is used to discover how many years or how old a fossil is? Professor Berger?
Okay. Well, we can both answer that. I'll answer in the short term. We use, both of us probably use mostly very similar means. We use radiometric dating, that is looking at the decay of various radioactive isotopes. People have heard of carbon-14, for example. That's good back to about 45 or 50,000 years ago. We've pioneered with our colleagues here to work on southern African sites, things like uranium-lead dating, which looks at the decay of uranium towards its inert state of lead, and we can date relatively accurately with that within, say, error bars of 2.5 to 5%. So those are what we call absolute dating methods, and they tend to be around radioactive decay. Then there are many other ways. We can look at comparisons between faunal and well-dated sites that are radiometric and look at if the faunal communities are the same. We can also look at things like the reversal of the Earth's magnetic poles. And sometimes the Earth's north has been in the south, and the south has been in the north, and we can see those flip-flops in deep-sea cores. And if we find accurate if we find good sediments that have been laid slowly by water, we can use that. So there's a wide variety of different methods that we bring together to date any fossil site that we have. And Bruce may want to elaborate on that.
Well, there's nothing more that I need to say, but it is a very specialized branch of science that does dating. And so Lee and I don't directly ourselves get involved. We work with animals and the bones that come out. But we send our rock samples to laboratories that are specialized to do dating. And I think the remarkable thing about dating technology is that it's improving all the time. And the
dates we're getting now are remarkably accurate compared to dates obtained 2, 3, 4, 5 years ago. So it's wonderful to be able to get these new techniques, and especially in the caves now. I think the EU people have pioneered a whole lot of new technology and techniques that have given you quite exciting dates.
Sure, Bruce. One of the problems that Southern African fossil record had, and the reason there was such a preponderance of work in East Africa, is they could date those sites very accurately. And things like potassium-argon dating, which is looking at potassium that is held up in argon gas, which is held up in volcanic crystals. But we didn't have a way to date the South African sites, and in fact we've had major breakthroughs, so we can produce some of the most accurate dates of our deposits of any sites in archaeological or paleontological, using largely uranium lead. So that, for example, I can tell you that the Australopithecus sediba fossils are dated to 1.988 million years before present, with an error of 1,500 years. So that's a 1,500 year error in 2 million years. That's pretty good by our standards.
Wow. And talking about dating, here's a question with regards to what came first. Andre Mainhardt asked, does the latest discoveries mean the history of origins of humankind is therefore older than the discoveries in East Africa, and the scientific Adam and Eve, is that from Southern Africa?
Excellent question. Older's not always best. The oldest fossils of hominins, bipedal apes, that is members of the family tree of humankind that walk on two legs, are still so far found in East Africa. Most of the fossils that we are examining now appear to be sites so far that we have announced range in the sort of 1 million to 3 million range. The oldest hominins theoretically date 4 to 5 million years in age. So no, we still haven't found the oldest, but remember, part of the problem with the fossil record, it's where the fossils are actually preserved. And so far we haven't been digging or haven't located sites that are in that kind of time range. So the answer is, while those fossils have been found in East Africa, we don't know that those kind of forms exist here. And then, of course, the scientific Adam and Eve would be the genetic Adam and Eve, I presume, is the question being asked there. That's often called mitochondrial Eve and Y chromosome Adam. And that's where we trace the sort of genetic origins of humanity to a single male or a near single male or a single female that every living human being on this planet share a common genetic descent from. We used to say that they never met each other because mitochondrial Eve was clocked through genetic dating to live between, say, 150,000 and around 200 to 250,000 years ago, and poor Y chromosome Adam only dated to about 75,000 years ago. So they never met. That's because the common ancestor of males lived later than females. We can get into complexities of that in the classroom. But now new studies have shown those dates are coming closer together, and that probably both Y chromosome and mitochondrially date closer back to the 150, 200,000.
Professor Arlie Berger saying we'll get more into that in the classroom. Does that mean we come back tomorrow to get into the classroom? Because I'd like to, I'll tell you that. I really want to talk about the rising, I think it's called the Rising Star Expedition, and what is currently taking place, talking to the team here. But quickly, before we go there, Polisa asks, what can paleoscience tell us about human characteristics such as race?
Okay, that's a great question. And from genetics, which is a part of human paleontology, we can tell quite a lot about the origins of things. But we don't like to use the term race because actually that is an outdated term. What we talk about as paleoanthropologists is variation in humans, generally regionally adapted to climate, environments, and ecologies. And that there really is no race of humans. All you have to do is look around this room and see the blend of characters that occurred depending on where one's ancestry was when populations were isolated around the planet. But what is interesting is new discoveries of organic material preserved in the deeper fossil record are allowing us potentially to explore questions we didn't think we would be able to answer until relatively recently, like, for example, what were the skin color of some of these individuals that might have lived 1 million or 2 million years old. Now, I'm not going to give you that answer now. I'm saying that I don't give many answers to it. But I can tell you that there is now new evidence in the fossil record that might give us. Now, that's not so remarkable, I guess, even at depths of like 2 million years when Sediba lived, because the dinosaur people knew that all along. They've been even getting things like dinosaur feather color and things at depths times in the hundreds of millions of years. So it's not actually that surprising. There are going to be some great breakthroughs coming from the science.
Alrighty, I've got another question here that talks about how, Professor Berger, you spoke about how research was slowed down by the NP, the National Party, under apartheid. And I'm going to direct this to both of you and start with you, Professor Rubidge. How much influence does current politics and worldview have on the work that is being done by the Center of Excellence in Palaeosciences?
That's an interesting question, because I'd like to think that politics doesn't play a large role, but it does play a role. It has to play a role, because whoever the ruling party is, if they don't support the science, then we can't make progress. And I think that that's the wonderful thing of where we stand at the moment, is that we've had wonderful support from the Department of Science and Technology and the NRF in setting up the Centre of Excellence here at Wits University, and for exploring the wonderful history of the paleontological history that South Africa has. This is a wonderful continent, as I hope came through in my lecture, that has got rocks of all different ages, and it's one of the few continents in the world that you can explore things right from the origin of life, right through the origin of humanity, all in one country. And I think that right at the present stage, we're getting good support from the political powers of this country.
I think that it's important to add to that, you know, this area, these paleosciences, paleoanthropology, and Peru paleontology, are a strategic area of advantage for us. You can't do this science in other places. Some of these sciences are uniquely, endemically African sciences, and there are nowhere better poised to do it than places like here, like Wits University, University of South Africa, universities in Africa, to do the kind of science that we have. The government recognizes that. This is a science where we can profile the very best research, the very best discoveries on a world stage, and form a magnet for the entirety of the world's scientific community interested in these things to come here and work with us as colleagues, with us as the leaders in this science. And that's a wonderful thing. You've got to remember the basic point of this. We're writing an unwritten past through this exploration and discovery. We're telling the story of deep origins of every living organism on this planet, and we're telling the story of the single organism on this planet that has the capacity to examine history, that is human beings. And it's an African story. It's a story that we're very good at telling, and we have very good fossil record.
I like the fact that you mentioned that we're talking about African science taking place on the continent, and of course that goes with the stereotypes about the continent that we've heard about in the past. It would be wonderful to say politics doesn't play a part, but as you said earlier on, it does. So I want to talk about that in terms of how these new findings, how this exploration of African science is changing worldviews about the continent today. We'll talk about that when we come back. We're going to take a quick break, and when we come back, we're going to also be engaging the researchers that are working with Professor Lee Berger. They go deep underground. Humanes? No. Back after this.
Find our way out to the other side. We are the other side.
Elephant. On our holiday, we went to the coast and stayed at a 3-star guest house with an ocean view, breakfast area with loads of yummy food, big beds made for jumping, and all the TV channels I wanted.
Oh.
Experience quality accommodation, service and hospitality when you stay at one of our star-graded establishments. Visit tourismgrading.co.za to find out more.
The Minister of Science and Technology here at Palaeosciences, Ministers of SKA Africa the launch of the American antenna on the 27th of March 2014. This launch also forms part of South Africa's 20 years of democracy celebration. The talk shop coming to you from the NRF Science for Society lecture series. We are at Witwatersrand University, and we're looking at how Palaeoscience charts the course of humanity's past. We're joined here by our guest speakers, Professor Bruce Rubidge, who is the director of the NRF DST Center of Excellence in Palaeosciences and interim director of the Evolutionary Studies Institute at the University of the Witwatersrand, and Professor Lee R. Berger, research professor at the Evolutionary Studies Institute and an advisor for the Center of Excellence in Palaeosciences at the University of the Witwatersrand. And we are talking about how humanity originated and what we can learn from our past for how we then advance into the future today. And we are taking questions from our audience here in the lecture theatre, and you're also very welcome to join us and via SMS or call in, or you could just be listening and just wondering in amazement and awe at the information that is being imparted here tonight. That is also absolutely fine. The number to dial if you want to engage, 0891 104 207, 0891 104 207, or SMS 34701. SMS number is 34701, and SMSs are charged at R2. Professor Berger, please tell us more about the Rising Star expedition and the work undertaken by these particular researchers tonight. Deep in the caves.
The Rising Star expedition was an expedition held in November of last year to recover one of the most extraordinary assemblages of hominins that has ever been discovered. And they're still there in huge abundance. We just tapped the surface. I have to describe to you this most remarkable situation. They were found by Stephen Rick, who you will be able to speak to in just a moment, who went down deep into a cave underground in the cradle of humankind, some 40 meters underground, crawling into a slot that was 18 centimeters wide, that they had to squeeze through, going down 12 meters, literally risking their lives, to find these fossils. We put together, once I saw the images of that, an expedition. I put out, as modern scientists do, a Facebook ad to find appropriate scientists to assist us in recovering these fossils. Because not only did I need people with a master's or PhD degree in paleontology or archaeology or paleoanthropology, I needed tiny people with those skills and the skills to excavate these fossils. I put a Facebook ad out. 10 days later, I had 57 qualified applicants, 80% of which were young women who fit the criteria of being able to squeeze through an 18-centimeter slot and were not claustrophobic. And had done this kind of work before, and two of those that we eventually began to call underground astronauts, because they truly were heroic in that 16-day expedition. Marina and Becca are here. You'll notice Becca particularly fits that profile for the radio audience. She is very tiny and able to get into that. And in fact, just to let the audience know, we've actually, literally, they've just come out from underground. For the last 3 days, we've been underground constantly, pulling out more special fossils from this deposit. These people literally risk their lives on a daily basis to recover these fossils. And if anyone, by the way, wants to follow it, all you have to do is Google Rising Star Expedition. That will take you to the National Geographic mini blog, where you can literally see up-to-date our efforts to recover these fossils. You can see videos. You can actually interact with us there through Twitter and other aspects.
All right, so let's engage these scientists that are going underground. Would you like to start, Mr. Rick? Just your experience. I mean, here you are, we've been hearing from Professor Berger that you are going underground, squeezing yourself into spaces that none of us in our right minds would even think of doing, let alone actually do. And what this means for you, and the discoveries that you're making by risking your lives, as you say.
Well, for most of us, we became and we leave our paper to Oscars.
Okay.
We were given this chance to actually go out and explore these systems. When we got down to the bottom, we found this. It allowed everything to take place. But to be involved in the expedition itself and helping everyone out and getting through here and being able to explore further and more of the systems going on in the future, that was an incredible experience.
And the ladies that are part of this expedition, I just want to engage you in terms of very interesting the number of applications that came through to Professor Berger and the involvement of women in this field. I think it's absolutely amazing in terms of how we are changing perceptions around, you know, the whole gender issue. And a question was asked earlier on by Kolisa about race and what we're learning from Palaeoscience. I'd like to know, what are we learning about gender from Palaeoscience?
I think that for the expedition itself, it's an accident that it's all women on the project. It just happens that there are a lot of women coming into archaeology and paleoanthropology right now, and a lot of women also are having these skills, the corollary skills, the caving or rock climbing, being outdoors and being active like that. So it's an accident. I think that it's all women as the initial scientist team, but when we're actually working on the expedition, gender's not an issue. We have support cavers, Rick and Steve, that are helping us out the whole time, and we're in there excavating the fossils. It's all just a team effort.
Tell us about the work. I'm sure here you are in these spaces, as you say, excavating these fossils, and that must be long days that talk about hard work in these claustrophobic spaces.
Yeah, we generally, when we were at camp in November, briefing was at 6 a.m. We were usually in the cave by 7:30 in the morning. We had 6 excavators, so we could do shifts. Now that we're into the second phase, we're still starting at 7:30, but it's just Becca and I. And so we're doing roughly 6-hour shifts these days, coming out sort of in the afternoon. It's very physical. I mean, it's physically demanding work. Getting into the excavation chamber is obviously challenging. And we have a lot of the scars and bruises to prove it. But yeah, and then it's kneeling. Yeah.
Because I was going to say that it's painstaking work in small spaces.
Yeah, the excavation chamber is very cramped, and so there's not a lot of headroom. So even for us, we can't stand up in the actual area directly where we're excavating. So we're both kneeling essentially and crawling back and forth, and you're doing that for 6 hours. So yeah, after 2 days, Becca and I are just getting stiff again after a little break. But yeah, it's super interesting and lots of fun. And I think both of us would go down twice a day.
As Professor Berger has said, the fact that these men and women risk their lives on a daily basis for us to get more information, that is absolutely admirable. And I just want to say thank you. Thanks, guys. But I want to go back to the issue that I raised earlier on. Kolisa asked about what Palaeoscience can teach us about the issue or human characteristic like race. What does it say about gender and about how we've stereotyped what women can do and what men can do, and the even intellectual abilities of men and women?
Okay, well, you're actually generally, when you talk about that type of sex roles and sex differences and things, we do deal with that as paleoanthropologists. In the deep past, we examine things like sexual dimorphism to look at how the troops were possibly structured. Now, sexual dimorphism is the difference in body size between males and females. So we see, for example, gorillas with a very, very high degree of sexual dimorphism. They form patriarchal groups where a dominant male has these smaller bodied females, a harem situation. And as sexual dimorphism actually decreases, we tend to look at that as, interestingly, a shift in behavior. Now, I'm going to say something very surprising, probably to both people in this auditorium as well as listeners at home, and that is this: that human beings, we can tell from the fossil record, are probably one of the most peaceful mammals that have ever lived in the history of this planet. We are one of the least violent animals, intraspecifically, within our own species, that's ever lived. And I know everyone's going, wait, we fight wars, we kill millions of people. Don't look at the application of technology versus how we have evolved. And the reason I say that as a paleoanthropologist is that we see as one of the characters of modern humans is reduced sexual dimorphism. We actually have males and females very similar to each other in body size. Hominins, like us humans, have reduced their canine size so that males are more like females, and the reason for that is probably to reduce violence between males. That is, you've made male. Females have selected male humans to look more like females, and thus lower the violent interaction between each other. There is a real reason that 16-year-old human girls like to put certain type of boy bands on their stage. They often are looking for more effeminate type males to breed with. It's a character of us. We're a peaceful species.
And that is why men are now wearing big shirts and going for pedicures. Clearly it's evolution. I wanted to talk about how these discoveries that are taking place in East Africa and largely in Southern Africa today talk about the perceptions that have always been held about this continent, Africa. It's a dark continent. It's where advances not only in technology but even in science are seen as not coming from here. And yet here we are talking about African science. What does this mean today and how the rest of the world is now looking at this continent?
I think that Bruce can follow on with this, but as someone here at Wits University, part of this great Palaeosciences Center and the work going on here, we can certainly say that in many, many areas of our field of paleontology, paleoanthropology, that the work being done by the teams here in collaboration with scientists around the world is at the front of the science. We are quite literally transforming the science in almost every area, from technology to the way we do analyses, to even the way we work together as scientists, pushing ideas like open access, the free sharing of data. Those are things that are coming out of this continent now, and I do hope are transforming in many ways the very way we do science as well as scientific discoveries themselves.
I concur exactly with Lee. I think that it's an important thing for us to engage with international scientists, but we have such a remarkable resource in this country. The fossils that are coming out here are so wonderful and diverse over long time periods. And then there's the other thing, is that we're engaging with new technology to help us show up what we are finding. And scanning has revolutionized what we can look and see inside those rocks. I showed you that little burrow with those two little animals in there. All that you can see is a little bit of bone sticking out the one side. Because of scanning technology, we can look right inside that burrow and see what's gone on there. A day in the life of animals 252 million years ago. And this is an interesting thing, because we have a little carnivore in there, a mammal ancestor in the burrow, and preserved with him is an amphibian. They're both about, I suppose, 18 centimeters long is the length of those skeletons. And what happened was, well, we thought that it's quite clear. The one's a carnivore, the other one's not a carnivore, and the one obviously pulled the other one in and was going to eat him. But then we noticed that the amphibian, which was not the carnivore, had 7 broken ribs. And that strengthened our idea, definitely. That's the carnivore had pulled him in and broken his ribs. But then we looked and we found that there's signs of healing of those ribs. So that amphibian had had those broken ribs for at least 7 days and was actually alive in that burrow at the time that it was submerged. And the only way that we can explain that, the two complete different species of the same size found together in the same burrow in a confined space, is that amphibian must have crawled in there when the other one was sleeping. And we think that the one was hibernating, and so he allowed that other one in. Then what happened? The flood came, covered the water, and we found 252 million day of what happened 252 million years ago. Nobody else in the world has ever found it. And it comes to market.
Absolutely something to be proud of. I've got a couple of SMSs that are coming in, and they're all asking about the correlations between the human evolution that we've been talking about today and the story of creation. That is the basis of our religious text. But before we even go there, let's take Sebastian in Johannesburg. Sebastian, good evening. Sebastian, please may I ask you to speak up, sir? Yes, we can hear you now. Extinction event, Sebastian. That's Sebastian in Johannesburg. Thanks for the call. He asks, when we talk about an extinction event, exactly how much life is extinguished?
We define a major extinction event from anything between 65% of species going extinct to 90% of species. So the biggest extinction event that happened 252 million years ago and is well recorded in the rocks in the Peru in South Africa, that exterminated in marine life about 90% of species, and on land about 70% of species. So that's what we call a major extinction.
Okay, you answered there, Sebastian. The issue of human evolution and creation.
Well, since
Professor Berger's really forget it.
Since Bruce Rubidge is a career paleontologist, he should take this question. Just kidding. Okay. It's a question that comes up all the time. That is let me answer it in a broad term and in a specific term. One is religion in conflict with science? It can't be. Science is observation of the natural world processes, physical properties. It's real, it's what we do. We're explaining both the present as we do this and extending that present into the past. That's the questions that scientists ask. We don't ask questions of religion. Religion is about human issues of human truisms. What is good? What is evil? What is right? And what is wrong? Well, we don't ask those questions at all. That is a part of humanity, and it's fair to acknowledge that the vast majority of human beings on this planet would consider themselves spiritual in some way, to use perhaps a better term than religious. More than 80% of people would identify themselves as that. But what they're exploring, what religion is exploring, or should be exploring, is not how the natural processes and physical properties of this planet operate. It's exploring human issues, and it explores them in many, many different ways. I will say this, that science, what we do, which is testable, repeatable, etc., is not designed in the same way that religious studies are. And there are certain religious concepts like fundamentalism. If you believe that literal interpretations of any of the great books of religion, if you believe in literal interpretations of those, that will come in conflict with science. It will also come in conflict with reality. Many of the great texts don't mention things that we know exist today. If human beings can keep those things separate, well then that's probably where we should sit for right now. The idea that religion explores human issues like good and evil, right and wrong, which science does. I can't tell you whether it's right for you to reach across and murder Professor Rubidge. I can only tell you whether it would affect your biological reproductivity, and therefore it would be bad for your genetics to do so, but I can't tell you whether it's right or wrong. That's the job of religion. Because there could be a circumstance which could come up very quickly where you might consider it right to kill him, right? So that's the issues where I would like to see that humans in the past, I think, have been very good at keeping the reality of science separate from the ideas of faith and religion. It's actually been the relatively recent past where particularly some religious organizations have attempted to mix those two topics. They don't belong together.
Mr. Berger says they don't belong together, Professor Rubidge. You agree?
Well, I think it's very, very difficult to compare the two, and I agree with Lee that they should be kept separate. What is very interesting in the whole development of life on Earth, we can look at the development of life on Earth and see what has happened in the past. In the oldest rocks, we find the most primitive organisms, and they get more and more advanced with time. And then we end up in the more recent rocks, in the most recent rocks, with the origins of humankind.
Talking about rocks, Dawn in Cape Town asked the question, how is fracking going to affect all this? I think it's a fair question, considering what fracking actually does to the earth and the fossils that we're finding in the earth. Dawn is asking a legitimate question.
Yeah. I think that fracking in the Karoo is a big question at the moment, and it's the rock layers that it's targeting are about 4 kilometers below the surface, and we're not going to be able to see those fossils ever, because erosion is not going to take us down to 4 kilometers now. But what it will do is it will mess up those layers completely. You won't be able to see the fossils in those layers because it will crack them up, and so the fossils will be splintered completely. But they're not exposed to the surface anyhow, and they're 4 kilometers down.
Okay, all right, there you go, Dawn. I hope that you have been answered. It's been very interesting tonight, and the question is coming through from Frank, who says, what subjects do you need to take to follow this field? And I would also ask the same thing, Frank, especially considering that Professor Berger absolutely refuses to answer any questions and keeps saying, we'll explore that in the classroom, explore that in the classroom. Gentlemen?
You know, you can get into these fields of paleosciences, paleoanthropology, archaeology, geochronology in many different ways. Almost any field, really, of the sciences or natural sciences has a contribution to make to the study of the past. On my teams alone right now, there are more than 125 scientists, and they range from physicists to geologists to chemists to the type of people like us who study bones and everything in between. So to become involved with the study of history, and particularly prehistory and ancient past, become a scientist. If you don't want of any kind, and then involve yourself in these type of questions. But you don't even have to be a scientist too. We also engage with people who communicate this sort of science, like you, who are actually involved in communicating this science, and it's a critical part. Outreach is becoming hugely important. When we did the Rising Star expedition last November, we did an experiment with open access to the science, had communication online, in social media and stuff. We had almost 1 million followers across the platform over a 3-week period for a pure science story. And we need people who are communicating science like that in discovery and adventure in the past, even down to artists. There's no career that can't contribute to our understanding of ancient history.
Professor Rubidge, looking up?
Yes, I concur entirely with what Lee says, but if you're at school and you want to know what you need to study to become a paleontologist at Wits University, then I would say that you need to, if you're at school still, you need to do some science subjects like physical science, and maths is very important. Passing maths is essential for entrance into any bachelor's degree in science at a university. And then if you are wanting to study paleontology at Wits University, I think it's always a good thing if you have biology as a background, or geology as well, and maybe geography. Anything you'd like to add?
Well, as you move, into the subject areas, archaeology, paleontology, all these subjects are offered at almost any good university. Pursue those areas, find what you love, and then pursue what you love.
Well, good luck, Frank, and thank you very much for that question. That's how we wrap it up with our speakers tonight. Professor Rubidge, Director of the NRF DST Center of Excellence in Palaeosciences and Interim Director of the Evolutionary Studies Institute at the University of Witwatersrand, and Professor Berger, Research Professor at the Evolutionary Studies Institute and an advisor for the Center of Excellence in Palaeosciences at the University of Witwatersrand. Thank you very, very much for your time, gentlemen. Right now, though, it's time for our African affirmations brought to you by the SK Institute.
Ladies and gentlemen, as you exit, it turns out that the side doors have been locked. So when you get to the lift on the ground floor, just slightly to your right and go down that corridor and exit at the Great Hall.